Hey everybody, thanks for checking out our video today. Today we're going to look at a new chapter, Contextual Applications of Differentiation. All right, today we're going to look at two separate topics here, which are pretty similar in nature. That's why we're going to do them together. Topic 4.1, which is interpreting the meaning of the derivative in context, and 4.3, which is the rates of change in applied context other than motion. Okay, so really, in the last two units, all we've really focused on is finding derivative. Okay, next two chapters now, and starting here in Unit 4, we're going to start talking about what does a derivative mean in the context of a problem? What does it help us find? Okay. So really what we're going to do today is just look at a bunch of problems from old AP tests and talk about what the meaning is behind what we're looking at. Okay. So here's the first one from all the way back in 2001. The temperature in degrees Celsius of the water in the pond is the differentiable function W of time t. The table to the right shows the water temperature as recorded every 3 days over a 15-day period. Use data from the table to find an approximation for W prime of 12. So the computations and indicate units of measure. All right, the big thing here is approximation, okay, for W prime of 12. It's not saying to find W prime of 12 because we can't find W prime of 12 because we don't have a function of W, okay? But remember that a derivative is just an instantaneous rate of change, okay? And if we can't find the instantaneous rate of change, the best thing we can do is we can approximate it using an average rate of change, all right? So if we're looking at, we want to know the instantaneous rate of change here, the best thing we can do is use the 2 points that surround that number as best we can. So these 2 points, and we can find an average rate of change, and that'll be our approximate instantaneous rate of change. Okay, so W prime of 12 is going to approximately be 21 minus 24 over 15 minus 9. So negative 3 over 6, or negative 1/2 degrees Celsius per day, because the numerator there is in degrees Celsius, the denominator there is in days, so degrees Celsius per day. Okay. So sure, that's what that is. Now, what we're going to do today is talk about what that means in context of the problem. Okay. And what that means, we'll get through in a second here, but let's talk about when I'm asking you to interpret what that means, this is what I'm looking for. You have to make sure you mention 3 things in your answer. Okay, and we use the acronym NUT, N-U-T. The N stands for noun, the subject of the problem, and numerical value of that subject. U stands for units. Always remember to put units down there. And T is the time, and include the time at which this derivative was computed. Okay. So let's take our answer here of negative 1/2 degrees Celsius per day and interpret that in the problem, okay? So when we write this out, let's just basically rewrite the question out and say what our answer is in that answer, okay? So the question is talking about the temperature of the water. So we're going to say the temperature of the water in the pond. Okay, so that's the noun. That's what we're talking about. The temperature of the water in the pond. That's the N part. All right, now what is it doing? It's decreasing by 0.5 or 1/2, whatever. So I'm going to say 0.5 degrees Celsius per day. All right. And when is that happening? At t equals 12, or at the 12th day. Okay. So you can see I wrote my subject and its value. Okay, I put units down there, degrees Celsius and day, and I put the time, so the 12 was the time. That's how we interpret these problems. So let's take a look at another one from 2013. On a workday, The rate, G of T in tons per hour, which unprocessed gravel arrives at the gravel processing plant is modeled by G of T, where T is measured in hours from 0 to 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel, and during hours of operation, the plant processed gravel at a constant rate of 100 tons per hour. So the question, there's a lot more to this question on the AP test from 2013, but we're just going to look at part A. And part A says, what's G prime of 5? All right, so G prime of 5. Now, you could do this by hand, although it's not a good idea, because we see our little calculator icon indicates that this was a calculator problem. So all you need to do is put G of T into Y1 in your calculator, and then find G prime of 5 using one of the two methods that we talked about in class. Okay? And if you do that correctly, you should get approximately negative 24.5875. Okay? So what does that mean? Again, let's interpret that number now in context of the problem. So G, remember G up here, is the rate at which unprocessed gravel was arriving at a gravel processing plant. Okay? So this is the rate of the rate. In other words, so we're going to type this out. I'm going to use my typing as opposed to my handwriting here. We would say the rate at which the gravel is arriving at the gravel processing plant, or just the plant, is decreasing at a rate of 24.587 or 588. They would accept either of those answers. Tons per hour, or tons per hour squared, when at time T equals 5 hours. So again, there are a couple different things you could write there instead of what I wrote. You could write, you can decreasing by this number, you can write tons per hour squared, but everything that needs to be there is there. All right, what are we talking about? What are its numbers? What are its units? And when is it happening? And that's what we're looking for there. Okay? Example 3, we have the wind chill and temperature. Degrees Fahrenheit, a human feels based on the air temperature, and the wind velocity is going to be V. The air temperature is 32 degrees. The wind chill is given by, we have W of V, so that's going to be our function here, W of V, and it's valid for V equals 5 to 60. Okay? The question says find W prime of 20. Again, could we take this derivative by hand? Yes, but there's really no point in doing that when we have our calculators handy, right? So W prime of 20, you just find that right in your home screen there. You should be getting negative 0.2855 degrees Fahrenheit per miles per hour. But let's write this out in sentence form here. Okay, so the wind chill is decreasing by a rate, or at a rate, of 0.285 or 286 degrees Fahrenheit per mile per hour. And then don't forget time, right? When. So at the wind, sorry about that, at the wind, I'm having some trouble typing. Wind velocity, there we go. V equals 20 miles per hour. Apparently I should stick to writing. Okay, that's a pretty good answer there. Okay, everything that we need is in our answer. So that would be full points for that problem. All right, fourth one here. So now we're talking about from a 2010 test, talking about snow on a driveway. All right, so there's no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9, snow accumulates on the driveway at a rate modeled by F of t, cubic feet per hour, where t is measured in hours since midnight. At 6, Janet gets up and starts removing the snow from her driveway. The rate g of t in cubic feet per hour at which Janet removes snow from the driveway is modeled by g of t down there. Now again, there's like 4 points to this problem. There's 4 different questions to this problem, but we're only going to look at one part of it. This is part A. Find the rate of change of the volume of snow on the driveway at 8 a.m. Okay. Well, to do this, we're going to have to figure out an equation for the rate of change of the volume of snow. All right. So let's call this R of t. You can call it anything you want. We can call it S of t or whatever. I'm going to call it R of t for the rate. And how is it changing? Well, snow is falling at F of t, but Janet's removing it at g of t. So we're adding F of t, but we're subtracting g of t at the same time. Okay? So now we can find our numerical answer at R of 8. So R of 8 is going to be F of 8 minus g of 8. All right, F of 8, we're going to put 8 into here, but again, that's not something we want to do without a calculator. Good thing we have our calculators handy to us here. And if you do that correctly, F of 8 should be about 48.417 minus g of 8. G of 8 is 108. If we do that correctly, we should get about negative 59.583 is our answer, okay? So when we write this out, we want to make sure we write this out in sentence form here. And we can say the rate of change of the volume of snow on Janet's driveway is decreasing at a rate of 59.583 cubic feet per hour. Actually, I'm going to change a little bit of what I wrote there. I'm going to change this first couple words here. I'm going to say the amount of snow on Janet's driveway. We're not actually doing the rate of change changing. It's the amount of snow that's changing. So the amount of snow on Janet's driveway is decreasing at a rate of 59.583 cubic feet per hour. And we still got to finish that up. When is that happening? At t equals 8 hours. All right, number 5. Talking about penguin population on an island modeled by a differentiable function p of time t, where pt represents the number of penguins and t is measured in years, 0 to 40. There's 100,000 penguins on the island at t equals 0. Birth rates given by b of t, death rates given by d of t. What is the rate of change of the penguin population on the island at t equals 0? All right, so again, we're just going to make up a function here. We're going to call it r of t for the rate. Again, you can call it whatever you want. But that's going to be modeled by b of t, the amount of births, minus d of t, the amount of deaths at that time. All right, we want to know at 0, so we're just going to find r of 0, which is b of 0 minus d of 0. Okay, and if you put 0 in those, this is one we could probably do by hand here. This is going to be 1,000 minus 250. We have the calculator if we need it, but I don't think we need it for this one. So 750, which means the population is increasing on that year. Okay, so let's write out our sentence here. The amount of penguins on the island is increasing by 750 penguins per year. When? At time t equals 0 years. All right, and our last one today, problem about bananas. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t, where f of t is measured in pounds per hours and t is measured in hours, okay? After the store has been open for 3 hours, store employees start adding bananas back to the display table at a rate modeled by g of t. G of t is in the same units as f of t. So, two problems here we're going to talk about. The first one says find f prime of 7, use correct units, explain the meaning of f prime of 7 in context of the problem. Again, we have calculators handy to us here, so don't make this hard on yourselves. F prime of 7. Okay, use your home screen to find that. We should get approximately negative 8.11954. So what does that mean in context of the problem? The rate at which customers are removing bananas from the display stand or from the table is decreasing 8.119 or 8.120 pounds of bananas per hour or per hour squared. Okay, I'm not really sure why they said removing them. They could just say buying them, but that's the wording that was used in the problem. That's the wording we'll use in our answer. Okay? And then B is the number of pounds of bananas on the display table increasing or decreasing at 5. Okay? Well, remember, it's decreasing at this rate and increasing at this rate. All right? So if we can just figure out what g of 5 are and what f of 5 are and see which one's bigger. Okay? So I'm going to do g of 5 minus f of 5. And if that number is positive, then the amount of bananas is increasing. If that number is negative, then the amount of bananas is decreasing. So again, we can just use our home screen to do that. G of 5 minus f of 5, and we should get approximately negative 2.263. It doesn't matter what the number is. The fact of the matter is it's negative, which tells us that f of 5 must be greater than g of 5. Which tells us that number of pounds of bananas is decreasing. All right, so let's write that out one last time here. The number of pounds of bananas on the table is decreasing. Now, it doesn't ask you, the question doesn't ask you how quickly or what the rate is. All it says is it increasing or decreasing? So all we got to say is that it's decreasing at time t equals 5 hours. All right, give a reason for your answer. Our reason is right here, that f of 5 is bigger than g of 5. That's it. All right, that is it for our lesson here on these two topics, which are very similar. It's basically interpreting the meaning of derivatives. All right, thanks again for tuning in today. Next time we'll take a look at straight line motion, position, velocity, and acceleration.